Hi, everyone. So this is how you people can help me. You need to respond when I'm speaking, so I don't feel like I'm talking to myself. Do we agree? All right. It's nice to meet you all. My name is Chelsea Adetan. And just like she said, I'm a data analyst. I'm also transitioning into data engineering. And I've been in this space for 3 years, going to 4 years now. And I'm going to be speaking to you guys today about building predictive models for real-life Nigerian problems. So before I do that, I want to gauge my audience. I want to know the kind of people I'm speaking with. So I'm going to play a very, very short and quick game. It's called Put a Finger Down. Are we ready? All right, so I want you guys to put your hand up like this. And I'm going to ask a few questions. And if it applies to you or if it hits you, just put it down. Are we ready? All right, so the first question is, put a finger down if you've ever opened YouTube and YouTube recommended a video for you to watch. Did we get that? Put a finger down if you've ever opened YouTube and YouTube recommended a video for you to watch. All right. Put a finger down if you've ever gone to order for a product, maybe on Temu or on any of these e-commerce platforms, and they recommend something for you to buy. I've seen some ones that are not even going down at all. You put it to go to all this. Okay. Another one. This one is for football lovers. Put a finger down if you've ever tried to predict the outcome of a game. Let's say Chelsea versus Arsenal coming up very soon. Okay. By the way, I'm a chronic Chelsea fan, so any hater in the audience, I'm coming for you. So put a finger down if you've ever tried to predict the outcome of a game. All right. Put a finger down if you've ever tried to guess the price of a house just by looking at it. All right. And then finally, the last one, put a finger down if you are trying to, you're going somewhere new for the first time. You now use Google Maps to check the... All right, so how many of us still have our 5 fingers up? Nobody. That means you people have actually been using predictive analytics, but you just probably didn't know it. And I said all that so that you understand that this thing we're about to talk about is something that we do innately every single day, but you just don't know. So we're bringing this solution to real-life Nigerian problems. How can we use predictive analytics to solve Nigerian problems? Are we together now? All right. So let me play with your imagination a bit. Imagine if we could predict Nigeria's future, let's say in food production, let's say in our economy, in inflation, in our everyday life. If we could predict what will happen maybe next year, if we could predict the price of rice or fuel next year, how do you think we would react? How do you think we would plan? If you could predict that there will be traffic somewhere before you leave your house, how would you plan? Or how would that make things better? Just imagine as we play another quick game. So look at this picture, right? You can see the house. Look at the features of the house. It's located in Chevron. It is a 5-bedroom duplex. It has kitchen, it has POP. You guys know how expensive POP is. It has wardrobes, water heater, heat extractor, swimming pool. How much do you guys think this house will cost? I want some people to answer in the comment section. I don't know. Wait. Put Naira or Euros or... Let me know what I'm dealing with here. So, let me hear you.
1.5 billion naira.
1.5?
Yes.
Okay. Can we give it to somebody else? Can I give it to someone else? Wait. Okay, guys, please. Let someone speak. All right.
I think a billion naira.
A billion naira. Okay. 2 more people and then we'll continue.
Hello.
Look at the features well. Oh.
Yeah, 500 million naira.
500 million naira first. Last person. One more person.
950 million.
Who is that? Okay, 950 million. So, are you guys ready for the big review? It actually costs 450 million naira. Now, what we just tried to do is actually predictive analytics in its sense. So we looked at a picture of a house. We tried to imagine using the features. It's located in Chevron. It has POP and all these things. And you were trying to guess what the price will be like. So that is actually predictive analytics, but with guesswork. So what predictive analytics is doing is actually doing it in such a way that the answer you are getting will actually be correct. You're not just guessing this time around. You're not just assuming. You're actually trying to get the correct answer. You're actually trying to predict something, and then your answer is correct. So I think I've established a very good foundation here, right? We can go further. So, remember my topic is building predictive analytics for real-life Nigerian problems. So let's talk about Nigerian problems. I mean, these are things that we cannot relate to. I still face some of these problems today. On my way to this place, there was serious hold-up. It's part of our problems. I mean, if I start saying that you guys should list out the problems we have, we'll probably not live here after an hour. But I thought to list out some of the problems we are experiencing. First is food insecurity, food shortage. The fact that many of us don't know this, but there are places in Nigeria where there's no food, or there's food scarcity. That is, the food being produced is not enough for the amount of people in that place. There are places where, even in Lagos here, or places that are actually developed, that food is not enough. I mean, if you are producing rice, the rice you are producing is not enough for the amount of people we have in that place, which is a big problem. Second is traffic congestion. How many of us can relate to this one? I mean, we are all in Lagos, right? You can just wake up one day and you realize there's traffic, and somewhere that will take you 30 minutes to get to suddenly takes you 3 hours for no reason. Another problem is healthcare. The fact that there are hospitals in rural areas majorly that face overcrowding. The fact that they don't have enough resources for the people that are coming into that hospital. Maybe the hospital is so filled up that they cannot even accommodate the people that come to that hospital. We have energy shortages. I try to touch it up, but what I mean here is that we don't have uninterrupted power supply. NEPA can take light and then, your meeting will just go off, or your system can just go off. They could bring like now, then we'll all be happy. So we have this issue. More than that, we have places in Nigeria that have never seen light for years. Do we know that? We're in Lagos, so there's light. There are places in Nigeria that they have never had light before. We have economic instability, the fact that we have inflation. The price of fuel could be 1,000 today, and by next week, because of something, it changes to 2,000 or even worse. I mean, we've experienced this too. So, we can relate to all these problems. This is how I feel. I don't know if this is how you guys feel too. There's so much going on. There's so much to deal with in this country. How can we make it better? What if we had a way to prepare ahead for these problems instead of waiting for it to happen to us? Are you guys thinking about this? So what if we could actually prepare ahead for these problems? What if before next year we could get how much food would produce in such a way that we would know how many people would be able to take food or have food in the next year? What if we could know all these things ahead, right, before it's time? What if we could be proactive instead of being reactive? Now, there comes predictive analytics. And I think I've tried to explain this enough already, right, so that you understand what I'm trying to say. But in all essence, predictive analytics basically uses historical data, mathematical models, and patterns to make informed predictions about what might happen in the future. So what you're basically doing is you're taking data from the past, you're using algorithms, models to predict what will happen in the future. A lot of us probably don't use this feature, but on our phones, we have something called a weather forecast. And when you open your phone, it will tell you, oh, it's going to be rainy today, or it will be raining tomorrow in a particular place. That's supposed to help you prepare. So if you are going out on a particular day, you know to carry your umbrella, or to wear a hoodie or cardigan. So that's basically what predictive analytics is. But have you ever wondered, how did they know it will rain tomorrow? Because, I mean, nobody jumped into tomorrow. How did they know? What they did is they got data from the past regarding the weather condition in that area at that particular time. So they will gather the data from like as much as possible, maybe 10 years before, 5 years before, as much as they can get. And then they use these mathematical algorithms and models to predict what will happen, in the future. So let me bring it down to a lighter note. For instance, we have clubs here that have never won trophies, in the past 5 years, I think. Arsenal, can you guys relate to that? I think so. So if I want to know if Arsenal will win a trophy this season, what do I have to do, guys? I just have to check the last 5 years and see, have they won any trophy? So that means what? Okay, so that is That's on a very light note, right? So that tells you, I'm trying to give you guys an idea of how these things work, right? So you use data from the past regarding that problem, and you try to solve a problem in the future. You try to know what will happen in the future before we even get there. So how can these things actually help our own problems? We're going to get there. So this is just a statistics to further convince you guys of the importance of predictive analytics. Companies or businesses who use this are 23% more likely to outperform their competitors in terms of getting customers. So even, not just the government, not just our country, even as a business owner, as a company owner, you do have to use predictive analytics. A lot of these big companies we patronize actually use predictive analytics. I can give you an instance. If you go on Google today and you search for how to cook jollof rice, the next time you are going back to Google, you would realize that they will start recommending things relating to food and jollof rice. Have we ever noticed that before? So you could go on YouTube today to search for Chelsea versus Arsenal 5-0 rewatch or rematch or highlight. And then you watch that. By the time you leave, you come back, they'll start showing you another Chelsea's Premier League match, recommending it to you to watch. That is predictive analytics in play. So what did they do? They took your search history, they took the things that you've searched for, right, to predict what you would probably be interested in. It's as simple as that. So they use that to make you feel like, you are being seen. Like if you go on a place, you feel like, oh, these people even know what I want before I open the app. It will make you hooked. It will make you want to stay. So there's no big company thriving out there that doesn't actually use predictive analytics. So how does it actually work? I mean, we've established the foundation, predictive analytics. We established that, we have plenty of problems in Nigeria. So how does predictive analytics work? First thing is to define the problem. So what do you want to predict? If it's the case of weather, what do you want to predict? Do you want to know if rain will fall tomorrow? If it's the case of food, do you want to know how much rice will produce next year? What do you want to actually predict? So you need to first know the problem. Secondly is to get the data. This is the part that can be stressful because especially if we're talking about Nigerian projects or Nigerian models, it could be a bit hard to find Nigerian data, but they exist. They actually exist. So you need to get the data, get the historical data you need for building that model. The third thing is to pre-process. So this is just a fancy word for saying clean the data. So many times, data you would get that you want to use to build your model might contain errors. We could have misspelled errors, we could have missing values, duplicates. Even apart from all those simple things, you could have a bias in the data. So take, for instance, you want to build a model to predict something for male and female, and your data only contains something about female. That's already a bias in the data that you would have to work on, or else it will affect the model you are building. So after getting the data, you don't just go ahead to start building your model. You actually clean the data to be sure that it's good enough for the model. Then number 4 is to actually build the model. I keep saying model, model, model. It's basically just mathematical algorithms that you use to check patterns in the data and predict what will happen based on the patterns you are seeing from that data. And when you are done with building the model, the next thing is to validate and deploy your results. So when you build a model, you don't just go ahead to start using the model. It could be wrong. There could be an error in your data. There could be an error even with the model that you have to check. So there are features or functions or formulas you can use to actually validate the model you built to be sure that that model is good enough to be deployed. So when the model is validated, is good enough, you've tested it with those functions and formulas, you can then go ahead to deploy your model. So now go ahead to use it to predict, the future or whatever you want to actually predict. So these are some of other examples of predictive analytics in use. One is predicting customer churn to improve retention strategies. So imagine I have an Amala restaurant, and then after getting my data, I realized for the past 6 months, my customers have been going. I could use predictive analytics to, get data and predict how many more customers or how that would go for the next 6 months. If I see that it's still going to keep declining, I then work on it. So what have I done? I've been able to predict what will happen in the future, and I've been able to get insight from that will improve the way I actually operate my business. That will improve the way I operate my business in such a way that I'll be able to keep my customers. So with predictive analytics, I could predict what the customer churn rates will look like, and I was able to now use that information to better my business. So that's one way of using predictive analytics. Another way is predicting students' performance. I really, really do hope we get to the point where this is effected in our educational system. or we're predicting students' performance and dropout rate. So there's a way you can also predict if a student is likely to fail an exam. And then if you know a student is likely to fail an exam, you can then focus on that particular student and see how that issue can be resolved. Another one is analyzing player performance to predict game outcomes. So, like I said, I watch ball a lot. So I know when you want to play these big Premier League games, before the match, you would have, football, people that are experts sit down and then they'll start analyzing, the players and what will happen before that match. So what they do is, for instance, if it's Chelsea, maybe versus Man U, they'll pick somebody like Cole Palmer, and then they'll put him on the screen. They'll show, 10 goals scored in 10 matches. Number of off-target goals. So what they're actually trying to do is they're trying to analyze the player to see from that statistics what he would do in that game. If, based on the statistics, you will be able to actually score or perform very well in that particular game. So predictive analytics is also in use, even in sports. We also have forecasting crop yield based on weather, soil, and fertilizer data. So I spoke about this. I'm still going to talk about this. The fact that we could predict how much food would produce in the coming years. So you could also forecast crop yield based on the weather, based on temperature, based on land size. You could forecast what your food yield would be like. Maybe you're trying to do that for maize or for rice or for yam. You could forecast how much food you would produce in the coming years. And then finally, we have forecasting economic trends for policy planning. So I have something to tell you guys, even though we might not believe it. I was watching a video where one of the co-founders of one of the biggest banks in the US was saying that he and his team carried out an analysis to check the economic trend of different countries and compare it with how it will be like in the next 5 years. And according to him, he said Nigeria is one of the countries that has the best economy. That's for the next 5 years. Beautiful. So you could also forecast economic trends. You can forecast what our economy will be like in the coming years. All right, so I actually want to show you guys a practical use case. So enough cho. I want to show you people workings. So I want to show you people a project I worked on. And this project, I predicted the production yield for maize and yam using machine learning and using predictive analytics. So in a simple sense, what I did was to predict how much maize would produce from now till 2030, how much yam will produce from now till 2030, in such a way that with that information, we can better prepare ahead. So if we know that we are going to produce X amount of maize next year, we can better prepare ahead for probably adding more resources or putting plans in place so that the people who would not get food will be taken care of. So the steps I took was, one, collecting data collection, then data preparation, which is almost the same thing as pre-processing the data, cleaning it and ensuring that there are no errors, model training, that's building the model evaluation, and then model deployment. So for the data, like I said, it's a bit hard trying to find Nigerian data. So I actually use data from different countries as well as Nigeria. I got my data from places like Kaggle, which is a well-known data repository. I got from World Data Bank. I got from a particular database in Nigeria as well that has to do with agriculture. So these are snippets of the code I used. The first picture is showing me importing the libraries I used to actually build this model. Some of the libraries that are here, NumPy, Pandas, Matplotlib, Seaborn, and other libraries you can see on the screen. So these libraries are what had the features or the functions or formulas I needed embedded in them to build the model. So number 2 is showing the actual data set. So as you can see in my data set, what I have in my data, I have the country, I have the year. So I collected data as far back as 1990 down to 2013. So I have the country, I have the year, I have the yield value. So yield value is talking about the amount of food that was produced in that year. So let's say Nigeria, 1990, how much maize was produced or how much yam was produced. Then I had average rainfall, per year. So also feature that in. Remember when we were looking at the house, we had to look at the features to be able to guess the price, right? So it works the same way with this as well. You need to have some features to be able to predict. So the features I included, the year, the yield value, average rainfall for that year, pesticide value as well for that year, land area. So what was the area, what was the size of the land that was used for the prediction? Then average population for that year as well. How many people were existing in that country that year? All right. So those were the six or five now, six different features that were used for my model. Number three is showing me trying to clean the data. A lot of the code is not actually embedded here. I believe I should be able to release my slide after this session. So if you'd want to, check the code later, you could. So this was where I was cleaning the data, basically pre-processing, right? Over here is to see the trend over time. Remember, we're dealing with historical data. And I told you guys, I collected data from 1990 down to 2013. So for maize, this particular first graph is for maize data. You can see the trend. I want someone to answer, is this trend upward or downward? Is there an upward trend or downward trend? Good. So we can see that over time, from 1990 to 2013, it has been an upward trend, right, in the production. Same thing with rice. It has been an upward trend in the production. So that's for data exploration. Then the actual thing, which is model training. Like I said, model is a fancy way for fancy name for mathematical algorithm, but this is basically the code I use. So I used 3 different models. I tested the data with 3 different models. I used decision tree regression, random forest regression, and XGB regression. So differently, I tested the data differently with these 3 models. And then when I was done, I evaluated the data. And some of the key features or functions or formula used to evaluate data is MSC and R2. MSC stands for mean square error, and then R2, the R2 score as well. So this basically is just showing how the code for creating the model, and then the code for testing and evaluating the model as well. Then this graph shows me the result of my evaluation. So the whole point was to get which model performed better, which model was better out of all the models that were listed out here. And then I plotted this graph. So this one is for the maize, and then the other one is for the rice. And I plotted this graph showing the different models that was used against the MSC score for each of those models, and then the R2 score for each of those models. So when I was done evaluating and everything was good and fine, I picked the best performing model, and then I was able to predict from 2014 to 2030 how much maize would produce, and then from 2014 to 2030 as well, how much rice would produce. So that was the result of this particular project I embarked on. So with this project, knowing this, having this knowledge in mind, if this is released to the public, it could actually help the government prepare ahead for these scenarios, for this situation before they even occur. So the whole goal is that we are not being reactive. We're not waiting for the problem to happen. We are actually trying to find out what will happen ahead and then preparing ourselves ahead before that problem happens to us. Do we understand? So I want people to also note that predictive analytics will not really have any use if the person or persons involved are not proactive. So it's one thing to bring my information like, oh, I know this is the amount of maize we'll produce next year. You could just keep that information and not do anything about it. So the whole point lies in using that information and then taking action based on the information you've discovered. So from this model, these are the actions that can be carried out. Governments can plan ahead. They can plan storage. They can plan, putting more resources into ensuring that, maybe there's more land area, maybe there is more, crops to plant. All those things can be put in place in order to ensure that, our chances are higher, chances of producing more food. Farmers can get better advice on how much to plant. So from this model, we can see that if you plant a certain amount of seed on a certain area of land, this is the output we will get. So knowing this, farmers can be advised on how much they should plant, what else they could plant to better our chances. NGOs and investors can identify high-risk regions and intervene early. So with this model, you could also know which particular area would have this particular amount of food. So with that, you could also, that would direct people like institutions like NGOs or investors to know where exactly to direct their funding or help to. Then this also aligns with SDG 2 goal, which is zero hunger. So this last line is very important. I need you to note that we're not trying to eliminate the essence of uncertainty. You can't actually know everything. You can't know the entire future. You can't see everything, right? But it would help reduce guesswork. It will help reduce assumptions. It will help reduce the fact that we don't know what's happening. With this, we can get an insight. It might not be the clearest, but we can have an insight into what would happen and we can prepare ahead for it. So, remember those problems I listed at the beginning of my session? I'm wrapping up now, right? The food insecurity, the traffic congestion, healthcare access, energy shortages, economic instability. Now, what happens after you apply this predictive analysis or predictive modeling to these problems? For food insecurity, machine learning can now help you predict food shortages. Just like I showed you guys with that project, we have been able to predict for maize, for yam, how much we would produce in a few years to come. And with that, we can now take action. For traffic congestion, I believe we'll get to the point where we can predict traffic patterns, where we can predict if there will be traffic on a particular road or not. I do believe Google Map uses this, because when you're trying to check the route from place A to place B, it's going to show you, you would know if there's traffic or not. Do we know that? You would see, when there's traffic, you will see the red color. If a place is congested but it's not traffic, you will see yellow, right? So I believe we'll get to that point. Predictive analytics can also help hospitals plan for patient demand ahead of time. If you could predict, what the patient inflow will look like in the coming years, if you could predict how much space you would need in the coming years, you could plan ahead. Machine learning can also help forecast energy needs. It can help figure out those places that need more energy, those places that have never had power supply or energy before. Economic instability, just like I said, the co-owner of the bank in America, you can predict trends in inflation for different countries or different companies. You can predict trend in inflation, you can predict the trend of unemployment, poverty, and you can then take action to stabilize the economy. Note again, all this has no impact if the person or governments we are dealing with is not proactive. So the whole point lies in taking the information you've gotten and then using it to actually get a solution, to be proactive, to prepare us ahead before that even happens. And I did not add this, but let me add it. I can also predict the outcome of Chelsea-Arsenal's match coming up very soon, based on history. So, in conclusion, I said all that to say we should all have the mind of using predictive analytics, not just in the government, but even in your personal life, where you work, in the company where you work, in your business, wherever you do. You should have plans to involve predictive analytics in whatever you do, as we can see the numerous benefits that it brings to us. And we can also see how this would help Nigeria's problems. And I'm going to end with this. Predictive analytics is not supposed to eliminate uncertainty, but it is supposed to reduce guesswork and help us better prepare ahead for problems before they get here. Thank you very much, guys. You can catch me on LinkedIn, and you can catch me on X as Data Magician. So I'll be taking questions now. Any questions? Wow. All right, thank you.
Hello, Chelsea.
Hi.
I want to ask, what type of exploration do you do for your data? In my opinion, I do feel like in the data science space, some people do expect you to also be a data analyst. So in your notebook, when you do the exploratory data analysis, do you do just for the data science, or you also implement the analytics into it?
All right, thank you for that question. So this would be a bit biased for me because I'm actually a data analyst, right? So if I'm approaching a data set or a product like that, I'm going to come from the analysis point of view. But the data sciences, basically exploration, whether you're a data analyst or data scientist, is basically you showing the trend in the data, in the historical data you have. So if it's a bar chart, like the one I showed, showing the different year and the yield value, it could just be a bar chart showing, you're basically just trying to show with visuals, right, what your data is saying right now. So do you need to be a data analyst? I don't think so, no. right? But you just need to show your data, the trend in your data. I believe that's also embedded in a data scientist work job description, rather. So I don't know if I answered your question.
I sorry.
No, you still want to speak. All right.
Okay. I get what you're saying, but isn't the model to tell us what is important or not? Because the
Yes.
essence of being
So,
doing
so
the
your
data.
model is to tell you what will happen, not what has happened. That's the whole point of exploration. You are trying to check what. So I asked you guys. So based on the data I had, did we have a upward trend or downward trend? That's me trying to know what has happened in the past. The model will tell you what will happen in the future, not what has happened before. That's where the place of data exploration comes in. You trying to understand, based on the data you've collected, what has happened. Do you understand?
All right.
Hello. So my question is around how do you accommodate for changes in variables? A good example is, say we are predicting the outcome of a football match based on historical data. How do you accommodate for things like, oh, okay, this team signed a new player, like say like Chelsea signed Mbappe, and like they've been like, things like that.
Just
And
send Mbappe.
yeah, like yeah, an example in
Salazar.
in farming is if say a new way to increase the yield of a new technology to increase the yield um of crop is coming out by 2026, and we're expecting that. So how do you accommodate changes in variables like that in your prediction?
So that is actually a very valid issue when it comes to building models. And it all falls down to the data you collect. Right? So this is part of the issues I was saying when we were pre-processing data. Your model will be as good as your data is. So your data should incorporate all these variables. If Chelsea is signing Mbappe, it will show in your data. Do you understand? So the model will perform as good as your data is, right? Let your data incorporate all these variables that could possibly pop up. Thank you.
Okay, thank you for this section. I want to ask just two questions. So the first one is um, the problem, I believe the main problem in building predictive models or any models for Nigeria is actually the data. So there's this for even after getting data, there's high probability is bias that it doesn't really support the Nigerian system or maybe African in general. So you were saying those data exist and we can get them. I'm not sure you said where, like a specific place we can get them. And second question is Messi or Ronaldo.
Sorry, what did you say?
Messi or Ronaldo?
Actually, my goat, I don't support either Messi or Ronaldo. My goat is Kopama. You guys know now. All right. On a serious note now, your question was, yes, where can you get data? So I'm not sure I said there's enough data for Nigeria. I'm actually pretty sure I said there isn't because we don't have as much data as we should, actually. In fact, this is a call to action. If you are going to work on a project like this, I would recommend that you actually try to get the data yourself. Like, don't go online to try to find, because we don't have as much as we should. When I was still in university, one of my lecturers was telling us that she published a data set collected herself online, and like it went viral because people actually need Nigerian data. People need to know what's happening in our country. So if you're in any position to get data, right, for a Nigerian project, try to actually get the data. Now, for this project, though, I mentioned Cargo, then I mentioned World Data Bank, and an agricultural database for Nigeria, but I can't remember the name anymore. So how do we do this? You guys can find me here. So I'm going to post and add all those things to my post. So you can either find me on LinkedIn. I'm quite active on these two platforms, right? So I hope that should answer your question. Are you a Chelsea fan? I'll block you from seeing my post. All right, thank you very much. Are there any other questions? All right.
Okay, thank you. I'm not a data analyst, by the way, but from what you explained and from your example that you did analysis on food production and everything, I realized that you took production rates, how many yams, and all this stuff. But then let's take Nigeria for an example now. How do you predict rates of things like insecurity? How do I call it? Like affecting the production rates. Let's say we know that farmers produced 30,000 yams last year.
Sure.
How can we predict that, okay, this year we are not going to get less because those farmers were chased out of their own farms? Do you understand what I mean?
Yeah, definitely. So that actually falls under future steps regarding this particular project. And it also goes back to the data. This data can actually be gotten if we choose to go out to the field to get the data ourselves, right? So this is definitely something I will work on. Like I said, your model is as good as the data you are working with. So this is definitely like a future step for adding more to my data to be able to give the context more model, give the model a context, right? It knows that, you are dealing in a country where there's insecurity. It's possible that, a farmer is chased out of his land and then is not able to plant. All these things could actually be included in my data for future steps. Thank you.
Good afternoon.
Good afternoon.
Yeah, just wanted to ask, with the emergence of artificial intelligence, do you think data analysts will be useful in 5 years, 10 years from now?
Wow, it took me out of my topic. It's another topic that I hold so dear. I don't believe, so this is my opinion, personal opinion, guys. I do not believe AI can replace anybody. Whether you're a data analyst, whether you're a data scientist, cybersecurity professional, whatever you are doing, I do not believe AI can replace anyone, right? What I would just advise is that you also keep improving yourself and get to the point where you can actually use AI. We're the ones that will use AI. People come to me and ask me, what if I can tell an AI to just do the analysis for this project and it will work? Let me tell you the truth. It takes a data analyst to use an AI to do an actual data analysis project. Somebody who has no idea about data analysis can never use an AI to get a good result. Quote me anywhere. So AI can never replace you. It cannot replace anybody. Personal opinion, I'm not about to argue with anybody. AI cannot replace you. Just on your own end, right, work on getting better. Work on, ensuring that you are abreast of all these trends. You actually know how to use AI. You should not be the one battling with ChatGPT prompts, right? Know how to do all these things. AI is supposed to actually make work better and easier for us, not to replace us. Thank you. Thank you. Do we still have questions?
Yes. Good afternoon, everyone.
Oh, okay, sorry.
Yes, my question, a lot of people have asked about different variables or different future steps going back into the problem statements. Like, for example, the problem statement we had, and then you showed us the steps and then the model. So now, if I have the last question the person said about insecurity, that insecurity factor now, is it like all of the problems that you could encounter has been put into the model before we have the final result? Or for example, say this model you're presenting to maybe stakeholders or business managers or the government that wants to use this model, and then they ask the question, is it already incorporated inside? And you're like, we had already, or there are different models for different...
So I actually get your question. So you're asking, is it, whatever context, the insecurity and likes, is it going to be in the data, or it just be like something you're saying after you've built the model?
Yes, or you can always go back, tweak, then show.
So it should actually be included in your data. It is all these things that give context. I don't know how to explain context, but you are trying to tell the model, this and this is what you should focus on. This is the idea. This is what you should know, right? It's possible to just give it, generic data that will just make it predict generically. But putting all these things like insecurity and the likes gives it context to focus on. That way your results will be more accurate. So like I said, your model is as good as the richness of your data, basically. So all these things should be included in your data.
Thank you.
Any questions? All right.
Okay, thank you very much.
I just want to ask that how large should your data bank be for cases where you have to predict things that are very complex? For example, so let's say you want to predict if whether an antibiotic is going to work for a particular disease or issue, because as you know, some of the diseases they learn to adapt to some antibiotics. So that's very quite complex. So how large should your typical data bank be in such a way that your prediction is going to be accurate?
All right, thank you very much for that question. So regarding this, I'm not going to put a number or a statistic or whatnot to it. Here's what I'm going to say. The larger your data, the better it is for your model. So get as much data as you can. Like if you get data and you realize, oh, I can still get more data regarding this thing, get the more data. The data cannot be too much. It can only be too small. So get as much data as you can. I can't really put a number to it, but get as much data as you can. Like let data you're working with be the most. Like there's no other way to get more data. So I think that should help answer your question. Oh, okay. All right, last person.
Okay, thank you so much. My question has to do with deployment. Yeah, apart from Streamlit, what are other platforms we can use to deploy our models easily?
So I didn't deploy mine with Streamlit though. I actually deployed it in my Jupyter notebook with Python, basically. But if you are working with, let's say you want it to be live on a website, that would not be on you. That would be the web, developers to know how they are going to incorporate the model into, the platform you are trying to deploy it to. So I did not use Streamlit. I just used Jupyter Notebook. All right, so I think that will be all from me. Thank you very much, everyone.